All right, what's going on, pre-calc? I am going to try to act like I'm in a good mood right now. I am in a terrible mood. I'm sitting here on the couch, and my Titans are losing 38-13, and the fourth quarter is just now starting. Not an ideal start. We have looked pitiful, and I'm sitting here still wearing my Titans gear. I don't know why. If it looks a little wet, it's just my tears from today, so just ignore that. But let's talk unit circle here. We have a test this week. Friday is part one of this unit. It's been a long unit, just kind of starting slow to the year. I didn't want us to rush, and so the unit is framed around this unit circle concept, I should say. It has to do with triangles. This is kind of the building blocks for trigonometry. And so in this video, I'm going to go over about 3 or 4 things that I promise you will be on the test on Friday, just so that you know it's relevant and that hopefully you'll be ready when you see it and not surprised. So the first thing that I want to remind you of is this idea of what a coterminal angle is. And I think I can show you visually better. Like, remember, a full spin is 360 degrees, right? So we will draw our initial side of our angle. It always starts there. And let's say I spin around to here. Okay, that's 150 degrees. That's a 150 degree angle. 150. A coterminal angle would be another angle that ends right here at this same spot. Because technically, it would look the exact same, but instead of 150, it would go all the way around and back. So what would that be? Or maybe it was a negative angle. Maybe it went this direction. That would also be in the same spot. You with me? So the way to find coterminal angles is simple. You either add or subtract one full spin, and you will get right back to the same spot. Okay? So if we add 360, we would get the positive coterminal angle of 510 degrees. And if we subtracted 360, we would get the negative angle of negative 210 degrees. And all 3 of these angles right here would look just like the one drawn. The only distinguisher would be if I drew the direction. So that would be a 150. Let's draw a negative 210. That'd be that one. That'd be negative 210. And let's draw a 510. That would be a full spin plus more. So coterminal angles, you add or subtract 360. But what if I give it to you in radians? What if I said, so that was 150. What's 150 in radians? That's 5 pi over 6. How would I give a coterminal in radians? Well, instead of adding 360, we add or subtract 2 pi, which is one full spin. So you'd have to work with some fractions and go over here and you do 5 pi over 6 plus 2 pi, which in order to add those, we need to put the 2 pi in terms of 6, something over 6, which would be 12 pi over 6. See how that's still 2 pi? It's just now we can add these quickly and get 17 pi over 6. And same thing could be true if we subtracted. 5 pi over 6 minus 2 pi would give us negative 7 pi over 6. So as you can see, 5 pi over 6, 17 pi over 6, and negative 7 pi over 6 are all coterminals. So that's one idea that you're going to see again. And just remember, because I'm using this to teach you things. I can't tell you every single problem that's going to be, on the test. But I'll just say you need to know your radians around the unit circle and kind of how radians operate. You need to know that one full spin is 2 pi. You need to know that a half of a spin is 1 pi. That you need to know that pi is equal to 180 degrees. You need to know that. Okay, you'll use it in a couple other contexts. All right, moving on. There is going to be a free response question on your test, and I'm giving you the question ahead of time. So there's no excuse for you to do well, I hope. We'll do some more in the year where I won't give you a tip, but this one I am. Here's the question. I'm actually going to type it. What is the unit circle? And where do the values come from on the unit circle? And by values, I'm talking about like the 0, the 1/2, the √2/2, the √3/2, the 1. I'm talking about these values. This is the point 0, 1. This is the point √3/2, 1/2, and so on and so forth. So what is the unit circle and where do these values come from? Here's the answer to that free response question. First thing you got to say about the unit circle is that it is a circle with a radius of 1. That's why it's called the unit circle. So all of these, this is 1, 1, 1. I could draw it all the way around. Those have a length of 1. And it's centered at the origin, 0, 0. Centered at the origin. And it's on top of the coordinate plane. Okay, it's on the, how do we want to do that? We can just say it's on the XY plane. It's on the coordinate plane. So the unit circle is a circle with a radius of 1 that is centered at 0, 0 on the coordinate plane. That's important to know because without knowing that, we're just making up values as we work our way around. Okay? The next thing is where do these values come from? And the key concept that I need you to take away and be able to express verbally is that it comes from the relationship between the special right triangles that we've talked about a lot. Okay? What are the special right triangles? Special right triangles are triangles that are either 30, 60, 90 or 45, 45, 90. Those are the two special right triangles. 30, 60 can be flip-flopped to 60, 30, but you get the idea. And it's important because if you know just quadrant 1, like if you know that this is 30 degrees and you know that the hypotenuse is 1, then you know that with a 30, 60, 90 triangle, that the hypotenuse is double the length of the smaller side, so we can work backwards to 1/2. And you know that the smaller side is multiplied by √3 to get the longer side. And when you multiply 1/2 by √3, you get this. So those values that are out here, I'm highlighting them right now, they are built from a 30, 60, 90 triangle. So honestly, as long as you can go off to the side and draw a hypotenuse of 1, a 30, 60, 90, then you should be able to always know that the x is going to be √3/2 and the y is going to be 1/2. You can almost use that as a crutch to help you work your way around. It's not a crutch, it's actually the foundation of this stuff. So what else? Let's draw another one, but let's draw it over here. Let's draw this one. Okay, this is in quadrant 2. This angle is a 135-degree angle, but when we form the triangle, it's a 45-degree reference angle. Remember, your reference angles are that little distance between the angle and the x-axis. And it will always either be, your reference angles will always either be 0, 30, 45, 60, or 90. Because if it would never be more, because then you could go the different direction to the x-axis. So knowing this is a 45 degree and knowing that this is a hypotenuse of 1, I know that the relationship from the hypotenuse to the leg, or from the leg to the hypotenuse, is whatever this length is times √2 gives you your hypotenuse. So to work backwards, we have to divide by √2. And 1 divided by √2 rationalizes out to be the square root of 2/2, which is where these points come from. So to sum up this idea of what is the unit circle is a circle with a radius of 1 that sits on top of the coordinate plane, and the values around the edges, and here's the last phrase that you need to know, they are ordered pairs that are on the circle's arc. Notice I'm putting all these ordered pairs in. Okay? They're ordered pairs. They have an x-coordinate and a y-coordinate. They're actual distances. And where do they come from? They come from the lengths of the y value and the x value of the special right triangles. If you can draw that diagram or some similar diagram and include all of this information, I think you will receive full marks on that question. Okay, last thing, we're at the 11-minute mark. I think this will be a 14-minute video. Is how do we, let's just do one of these more challenging problems like this. Like what if we had the sine of 4 pi, let's go 5 pi over 6, 7 pi over 6, sorry, I'm wanting this to work out for you. Sine of 7 pi over 6 times the cosine of what equals 1/4. Let me just make that up. So you're like, what? The sine of 7 pi over 6 times cosine of blank equals 1/4? How am I supposed to know that, Smith? Well, you just take it one piece at a time. Let's work with what we do know. Let's find the sine of 7 pi over 6 first. Okay, sine of 7 pi over 6, the reference angle, it's a 6 on the bottom, so that's a 30 degree. It's in quadrant, it's one higher on top, so that's quadrant 3. So the answer of sine of 7 pi over 6 is whatever the sine of 30 is, which is 1/2. Quadrant 3 is negative. So sine of 7 pi over 6 is negative 1/2. So now, negative 1/2 times what would give me 1/4? We got to kind of work backwards. What would we need to go there in order for this equation to be true? And then we can pick what angle we think will make it true. So first, let's just go back to like middle school math. Negative 1/2 times what would give me 1/4? Well, I would need a negative times a negative to make the positive. And then 1/2 times what would be 1/4? That would be another 1/2. Negative, well, let's test it. Negative 1/2 times negative 1/2 is positive 1/4. Okay, so I now need to pick the angle measurement that can give me negative 1/2. So what reference angle with cosine gives me 1/2? That's actually 60. And then which quadrants is cosine negative in? Cosine is negative in quadrants 2 and 3. So that means there are actually two answers that I could choose. The 60-degree reference angle in the second quadrant and the third. So what is the 60 degree? 60 degree reference angle means that there's a 3 on the bottom, so I know that. And then I just need to pick the one that is in the second or the third quadrant. So what radian measure with a 3 on the bottom is in the second quadrant? That's one less on top. And then the third quadrant, that's one more on top. So either one of these answers would work. 2 pi over 3, cosine of 2 pi over 3, or cosine of 4 pi over 3 would make this equation true. So that's what I'm looking for. Okay, that's a lot. We talked about coterminals. We talked about the unit circle. Please take 2-3 minutes, jot down a couple things that you learned from this video, and then definitely anything that's not clicking, any questions that you have. We've got Tuesday review, Wednesday review, and that's it. So the time is now. No surprises on this. Lean in, study, come in the morning, let's work, because this is doable. This first unit is very doable. You guys have been making great progress. I just think if you lean in and you study up and you make math your priority this week, doesn't always have to be, but this week is test week, I think you can feel successful on that last week. So that's all I got for you. See you soon.